Welcome, Geometry, to Chapter 6, Polygons and Quadrilaterals. 6-1, pause, give it a try, and come on back. Number 1, a three-sided polygon, triangle. A four-sided polygon, quadrilateral. When you substitute 6, you have 24. Substitute 6, and you have 270. And solving for A, how many A's do we have here? Looks like we have 13 and 12, 25, right? So A equals 4. If you aced that, congratulations to you. Our objective today is to classify polygons based on their sides and angles, and to find and use the measures of interior and exterior angles of polygons. So just a little opening, little intro. Each segment that forms a polygon is a side of the polygon. So we have side AB, side BC, CD, and so on. These are all sides. AE is also a side. The common endpoint of two sides is a vertex, right? So C here is a vertex of the polygon. A segment that connects any two non-consecutive vertices is a diagonal. So BD is an example of a diagonal. If we connected two consecutive vertices, we would have a side of the polygon. So when we connect two non-consecutive sides, non-consecutive vertices, we have a diagonal. Good. So we have names, as we've heard before, of polygons based on the number of sides, right? So we reviewed this in 6th, 7th, and now again 8th grade. 3 sides, triangle. 4 sides to the polygon, quadrilateral. 5, pentagon. 6, hexagon. 7, heptagon. Sometimes people will refer to this one as a septagon. Number 8, octagon. 9, nonagon. 10, decagon, decad. 12, dodecagon. And then if we increase the number of sides above 12, we might just say it's a 20agon, and so on. So remember, a polygon is a closed plane figure formed by 3 or more segments that intersect only at their endpoints. So we are going to tell whether the figure is a polygon, and if it is, name it by the number of sides. So is this a polygon? Yes, it is a closed figure made up of segments, isn't it? So let's name it by the number of sides. 3, 4, 5, 6, 6 sides. So it would be called a hexagon. Good. Is this a polygon? If it is, name it. Well, is it a closed figure formed by segments? Yes, it is a polygon. And how many sides does it have? 1, 2, 3, 4, 5, 6, 7. Okay, we will call this a heptagon. Is this a polygon? And the answer is no, it is not. These are not segments, are they? These are curves, so this is not a polygon. Is this a polygon? If so, name it by the number of sides. It does have segments, however, this is not a closed figure. This has an opening, so this is not a polygon. All the sides are congruent in an equilateral polygon. Equal sides. All the angles are congruent in an equiangular polygon. So if we put both of these together and have an equilateral and equiangular polygon, we call that a regular polygon. It has equal angles and equal sides. If a polygon is not regular, it may be called irregular. Okay? So, we have 2 different types of polygons seen here. This is kind of the classic one we're used to. This looks like an isosceles trapezoid, doesn't it? If a polygon is considered concave or convex. So convex is our most familiar types of polygons, right? Concave, do you see this kind of caving in here? Concave quadrilaterals. When we draw a diagonal from these two non-consecutive vertices, this diagonal contains points outside of this quadrilateral, right? So we would call this a concave polygon. A convex polygon, when we draw the diagonals, no diagonal contains points in the exterior. Okay, it's only touching points in the interior, so it is called a convex polygon. Tell whether the polygon is regular or irregular. Tell whether it is concave or convex. So regular, remember, equiangular and equilateral. Is this regular or irregular? It is irregular, isn't it? We do not have equal sides in all cases. Is it concave or convex? Well, if I draw a diagonal here, I'm across, between those two vertices, the diagonal is only touching interior points, so it could be convex. However, when I draw a diagonal here between these two non-consecutive vertices, I'm touching exterior points. So it's caving in here, isn't it? We call this one a concave. Is this regular or irregular? Concave or convex? Okay, well, I see equilaterals. Do we have equiangulars? That's a problem. It looks like too acute, too obtuse. So this is not regular. Even though it has equilaterals, you must also have equiangulars, right? Equal angles. So it's irregular. Is it concave or convex? When we draw the diagonals, they are only touching interior points, so it is convex. Regular or irregular? Concave or convex? We would say this is regular and this is convex. Okay, find the sum of the interior angle measures of a convex polygon. If you would like to find the interior angle measures, a sum of them, you just need to draw all possible triangles from a particular one vertex of the polygon. This would create a set of triangles, the sum of which equals the sum of the angles of the measure of the entire polygon. Excuse me. So we know that the triangle sum theorem tells us there are 180 degrees in a triangle. In a quadrilateral, from a particular vertex, we can draw one diagonal forming two triangles, right? And so this quadrilateral, as all quadrilaterals, has 180 times 2 degrees in its 4 vertices, 360 degrees. A pentagon, if we start at this vertex, we can form 3 non-overlapping triangles, right? 2 diagonals, and therefore 3 times 180, 540, and so on. By the triangle sum theorem, the sum of the interior angle measures of a triangle is 180. So as we look at increasing numbers of sides in polygons, we can see that the number of triangles increases by 1 as we add an additional side to our polygon. If we would like to know the sum of the interior measures of a 6-sided figure, a 6-sided polygon has 4 triangles. 4 times 180 is 720. The relationship that you can see here is that the number of sides take away 2 gives you the number of triangles, doesn't it? that a polygon has. So we just multiply n minus 2 to 180, and we know the number of degrees in any polygon. Again, n is the number of sides for that polygon. In each convex polygon, the number of triangles formed is 2 less than the number of sides. This is called the polygon angle sum theorem. So let's find the interior angle measures and sums in polygons. If I find the measure of each interior angle of a regular 16gon. If it's 16gon, how many triangles would we find there? 16 minus 2 is 14. So we could say that the number of degrees in this triangle is 14 times 180, right? 2,520 degrees. If we wanted to know what one angle equaled in this interior of this triangle, or of this polygon, we would just divide the total number of degrees by the number of angles in this polygon, which is 16. And so when we do that, we find that each angle in the regular 16gon equals 157.5 degrees. Find the measure of each interior angle of this pentagon ABCDE. Because it's a pentagon, we know it has 5 sides. And if it has 5 sides, how many triangles could be formed from a single vertex? And we see 3. So we know that 3 times 180 is 540, right? And so now we can simply sum the angles, and their total should be 540, and we can find C, right? So let's see how this works. When we sum all the angles, we should have 540. So when we substitute the given expressions for the angles, we have all these C's, don't we? So we're going to add 35C, 18C, 32C, 32C, 18C. When you do, you end up with 135 C's. Okay? And so to find C, we simply divide by 135, right? And when we do, we get C equals 4. So if we want to find each of these angles, we just substitute 4, and we can do that. 18 times 4 would be what, 40, and 32, 72 degrees here. 32 times 4 would be 128, and we got it. Very good. Again, we just substitute the value for C, and we find the unknown angles. Another awesome relationship we see in polygons is that the exterior angles, if we sum them up for a given polygon, the sum of, in this case, the exterior angles for a triangle is, guess what, 360. And when we add the exterior angles of this, which is a 1, 2, 3, 4, 5, so it's a pentagon, the sum of the exterior angles is still 360. So it's circular, isn't it? Very good. We can use this relationship to find exterior angle. Remember, an exterior angle is formed by one side of a polygon and the extension of a consecutive side. Okay, this fact can be placed in this theorem, and the theorem states that the polygon's exterior angle sum, the sum of the exterior angle measures one angle at each vertex of a convex polygon is 360. Okay, we're short on time, just a minute left. Find the measure of each exterior angle of a regular 20gon. It's a regular 20gon, so each of the exterior angles will be equivalent. It's 20 exterior angles, right? And they sum to 360. So simply, we divide 360 by the number of sides in this regular polygon, and we know that each of the exterior angles is 18 degrees. To find the value, pause the video, give it a try. Again, this exterior angles will sum to 360. Find B. You should have found B equals 3. Pause the video if you need to walk through that, okay? Please pause the video and give this lesson quiz a try. Come on back and check it out. There you go. Check it out. And have fun. Enjoy.